The universe is vast, really vast. It's full of billions of galaxies, each with billions of stars. Many of these stars likely have planets. Some of these planets could be like Earth. They could have the right conditions for life. So, where is everyone? This question is the heart of the Fermi paradox. The paradox is named after physicist Enrico Fermi. He wondered why, given the universe's size and age, we haven't found any signs of alien civilizations. It's a puzzle that has intrigued scientists and the public for decades. We look up at the stars and wonder, are we alone? The Fermi paradox highlights a discrepancy between the high probability of extraterrestrial life and the lack of evidence for it. It leads us to some fascinating possibilities about the universe and our place in it. Are we overlooking something? Are we truly alone? Or are there other explanations waiting to be discovered? Our galaxy, the Milky Way, is just one of billions in the observable universe. It contains hundreds of billions of stars, many similar to our Sun. Recent discoveries have shown that planets are common, with many stars hosting their own planetary systems. If even a tiny fraction of these planets are habitable, the sheer number suggests the potential for life elsewhere in the universe is enormous. This vastness makes the absence of any contact from extraterrestrial civilizations even more perplexing. The universe is also ancient, about 13.8 billion years old. This means there has been plenty of time for life to emerge and evolve on other planets, potentially into advanced civilizations. So why haven't we heard from them? One possibility is that we are simply too early to the party. The universe might be teeming with life, but most of it could be in its early stages. Intelligent life, capable of interstellar communication, might be relatively rare and still developing. Imagine a vast cosmic calendar. If the universe's history were compressed into a single year, humans would have appeared in the last few seconds of December 31st. Advanced civilizations might have arisen and fallen long before we even existed. Perhaps other civilizations haven't had enough time to develop the technology for interstellar travel or communication. Or maybe they have, but their signals haven't reached us yet due to the vast distances involved. Section 4. Rare Earth. Are we one in a trillion? The rare Earth hypothesis takes a different approach. It suggests that the conditions that led to life on Earth are incredibly rare, even unique. It argues that a complex combination of factors, such as our planet's distance from the Sun, the presence of a large moon, and the influence of Jupiter, were crucial for life to arise and thrive. According to this hypothesis, while simple life forms might be common, complex, intelligent life like ours could be incredibly rare. We might be the only ones in our galaxy, or even the observable universe, who have reached this level of development. The rare Earth hypothesis is a sobering thought. It suggests that we might be a cosmic fluke, a lonely island of life in a vast and silent universe. Section 5. The Great Filter. A cosmic roadblock? The Great Filter hypothesis proposes that there are barriers or challenges that prevent life from developing into advanced civilizations capable of interstellar travel or communication. These filters could be anything from asteroid impacts and gamma-ray bursts to self-destruction through nuclear war or environmental degradation. This hypothesis suggests that most life in the universe might be wiped out before it reaches a certain level of advancement. If this is true, the big question becomes, where on the timeline of the Great Filter are we? Have we already passed it, suggesting that the path to advanced civilization is relatively clear? Or is it still ahead of us, posing a significant existential threat? The Great Filter is a stark reminder of the challenges and potential dangers that life faces as it evolves and progresses. Section 6. The Zoo Hypothesis. Are we the exhibit? The zoo hypothesis offers a more intriguing, albeit somewhat unsettling, explanation. It suggests that advanced alien civilizations are aware of us but choose to observe us from a distance, like animals in a zoo. They might be waiting for us to reach a certain level of technological or social maturity before making contact. This hypothesis raises fascinating questions about the ethics of interstellar contact and the motivations of advanced civilizations. Are they protecting us from something? Are they studying us for their own purposes? Or are they simply waiting for the right time to reveal themselves? The zoo hypothesis, while speculative, highlights the possibility that we are not as alone as we think, but also not necessarily in control of our cosmic narrative.